So in solving this differential equation, I have to split up the x's and the y's. And because this is multiplication, I can divide by y. And here I can divide by x squared minus 1. And so it means I have y, 1 over y, sorry, dy dx is equal to 2x over x squared minus 1. I am going to split up my differential, my derivative. And so it's going to be 1 over y dy is equal to 2x over x squared minus 1 dx by multiplying both sides by dx here. So now I want to solve this one so I can integrate both sides. When I integrate both sides, the left-hand side is ln y equals, when I integrate this right side, what I notice is that this 2x is the derivative of the bottom of the function. And so if I let u be x squared minus 1, du is 2x dx. And so I can integrate then 1 over u du, because 2x dx, this is du. And so when I integrate this ln y, I get ln u, which is just x squared minus 1 plus c. I only need 1 plus c. And because if it's a constant on this side, it adds over to the other side, so it doesn't make a difference. Okay, so I do know that y at 2 equals 9. All right, so if I take this scenario here, I will solve for y first before I do y at 2 equals 9. I'll use that to get c in a bit. But right now, I'm going to raise it this side to the power e and this side to the power e. So y is equal to, this is going to be x squared minus 1. Let me put a couple steps here before I make a careless mistake here. Okay, so I know it's going to be e to the ln x squared minus 1 times e to the c, because it's adding here, which is y is equal to, well, this is x squared minus 1. This is just some constant a, we'll call it. Finding out what a is, I'm going to use this point here, and 9 is equal to a 2 squared minus 1, and so a is going to be 3. And so this equation is y equals 3 x squared minus 1, and that is solving the differential equation.